In this video, we are going to prove a theorem that says a line from the center of the circle perpendicular to the chord bisects the chord. Ne? So what it says is if there's a line from the center, and remember AB is the chord, so this line OP, we can see they're showing us that it's perpendicular to the chord AB. Therefore, the theorem says if this is the case, AP must be the same as BP. Right. And this theorem is examinable, ladies and gentlemen. It can be asked in formal activities, formal tasks, like in exams and tests. Okay. So without wasting time, let's get to it. So here they say RTP, which means required to prove. So we are required to prove that AP is equals to PB. Ne? Perfect. So there are two ways to prove this. Okay. So I'll show you both ways, ne? And then you'll pick the one that you like. So the first one, we're going to say proof. You always write that you are doing your proof. And then you show, you see the dotted lines, they will never be given to you on the activity. They'll just give you the whole diagram, but without the dotted lines. This, we call it your construction. Ne? So you're always going to state it here. Whatever you add on the picture or the figure, you add it here. Construction, you're going to say draw what AO and OB. And then you can see that we drew them there, right? You always use dotted lines to add on anything that was not given. So we have drawn AO and OB. Now we can see, guys, that here we have two right angle triangles, which is this one and that one, right? So I'm going to prove it using Pythagoras first. Ne? Okay, perfect. You know that AO squared is equals to AP squared plus OP squared. And then your reason is Pythag, right? Pythagoras. You use the theorem of Pythagoras, right? And then you can see that also OB squared, which is the hypotenuse for this other right angle triangle, is the same as PB squared plus OP squared, right? Which also is Pythagoras. Pythagoras. And then, but ladies and gentlemen, we know that AO, right, and OB are equal. Why? They are radii, right? You can say equal radii. Remember, radius of the same circle, in plural we say radii. Ne? So the length from here to there is the same as the length from there to there. The reason is radius, right? The radius of the circle is equal. Therefore, we can conclude that AO, if we add the squares, is still going to be the same, right? So I introduced the square there, introduced the square there. But ladies and gentlemen, we know that AO squared is this guy, right? So I can replace AO squared with that. So I have A P squared plus O P squared equals to OB. We can see that it's PB squared plus O P squared. All right. And then if we check OP squared, will minus with that one. So they will cancel each other, right? It's like if I move this OP squared that side, it will cancel this one. Or if I move this one that side, it will cancel. So you're left with, okay? You're left with AP squared equals to PB squared. You can see that if you square root both sides, you have therefore AP equals to BP, which is proven. You always say proven at the end. Sure. This is the first way to do this proof. And then when you're doing your proofs, remember we need a reason. The reason for this theorem is always line, in short, from center, you'll say perpendicular chord. This is how you'll write your reason. Line from center, perpendicular chord. Perfect. So guys, the other way we can prove this is through congruency. Okay, let me just erase here. The other way to prove this is through congruency. Okay, so let's check now. To prove this through congruency, you're going to say, okay, but the construction is still the same. You don't change it. So it's going to say in triangle, you start here OPA. You go OPA. So triangle OPA. So remember, the letters are not always going to be O, P, B, and it can be anything. You just need to know how we move, right? It's from here to there, then there. And then you're going to say and triangle O, P, B. All right. And then you can see that, okay, OP is equals to OP because it's common sides between the two triangles, right? So it's going to be the same. So we're going to say common side, right? And then we know that AO or OA will be the same as OB, right? You can see the OA and OB are the same. Your reason is radii, right? And then you can see that angle APO, which is this one, right? It's 90 as well, right? Do you agree? It will be the same as angle BPO. Your reason is both 90 degrees. And then you can conclude that, therefore, triangle OPA is congruent. Congruent, you use 3 lines to triangle OPB. Your reason will be right-angled, hypotenuse, and side. So there was a common side, there was the hypotenuse, which are equal, they were 90 degrees. So this is the reason of congruence. You need to know all 4. Ne? But for this theorem, you're always going to use RHS. Therefore, you can conclude that AP is equals to PB. Your reason, you can say congruent triangles. And then finito. Right. Thank you very much, ladies and gentlemen. If you haven't subscribed and you found this video helpful, please subscribe to make sure that you're going to get more fire content like this. And don't forget to share with family and friends. Thank you very much. Aluta continua. Tango.